Good afternoon, students. I am Kavita Monga, lecturer physics at Government Polytechnic College, Khuni, Majra, Mohali. Today we will solve few numerical problems in optics. So to start with, let's define what is light. So light is a form of energy which helps us to see objects. When light falls on objects, it reflects the light, and when reflected light reaches our eyes, then we see the objects. So light help us in seeing the objects. Light travels in straight line, straight path follow करती है. The common phenomena of light are formation of shadows, formation of images by mirrors and lenses, bending of light by a medium, twinkling of star, formation of rainbows. So all these are phenomena which are exhibited by light. So light रिफ्लेक्ट होती है, रिफ्रैक्ट होती है, स्कैटर होती है, उससे डिफ्रैक्शन होती है, एंड लाइट ट्रेवल्स इन स्ट्रेट लाइन, एंड ऑल्सो लाइट इज अ फॉर्म ऑफ energy. So these few phenomena are shown here, exhibited here. This is reflection. Here this shows refraction. This is formation of a rainbow, and this is diffraction of light. So when a light ray it passes through a glass prism, it splits into its 7 color. So this phenomena, this is called diffraction. The overall study of how light behaves is called optics. So what is optics? This is the study of light. How light behaves is called optics. The branch of optics that focuses on the creation of images is called geometric optics, because it is based on relationships between angles and lines that describe light rays. So now what is geometric optics? So this is the branch of optics that focuses on the creation of images. Some more definitions. What is absorption, refraction, diffraction, dispersion? So absorption is when light passes through an object, the intensity is reduced depending upon the color absorbed. Thus the selective absorption of white light produces colored light. What is refraction? Change of the ray. When the ray passes from a transparent medium, it changes its direction. So this direction change of a ray light passing from one transparent medium to another with different optical density. So a ray from less to more dense medium is bent perpendicular to the surface with greater deviation for shorter wavelengths. So refraction is changing of path of light ray when it goes from one transparent medium to another transparent medium. What is diffraction? This is light rays bend around edges. New wave fronts are generated at sharp edges. The smaller the aperture, the lower the definition. Now next, what is dispersion? Dispersion is separation of light into its constituent wavelengths when entering a transparent medium. The change of refractive index with wavelengths such as the spectrum produced by a prism or a rainbow. So when a white light enters a prism, due to refraction, it splits into its 7 colors. So this phenomena, this is called dispersion. So this absorption is shown here, just see. So in this light 7 colors are there, but when a red filter is placed in the path, so what happened in absorption? So after passing through this red filter, there is no blue and green light. So this is what we mean by absorption. So this blue and green color has been absorbed by this filter. A lens is an optical device that is used to bend light in a specific way. So what are lenses? What are mirrors? A converging lens bends light so that the light rays come together at a point. So converging lens में rays they are converged, and a diverging lens it bends light so it spreads light apart instead of coming together. So convex lens is a converging lens and concave lens is a diverging lens, and lens is an optical device that is used to bend light. That means refraction. Refraction का phenomena is exhibited by lens. So a convex lens is shown here. Sun rays, they are focused, they are converging, and when they reach focus at a point and this hot spot, a paper can be burnt by this process. So convex lens is a converging lens and concave lens is a diverging lens. Mirrors, they reflect light and allow us to see ourselves. So mirrors में reflection होती है, lens में refraction होती है. A prism is another optical device that can cause light to change directions. So refraction, again the phenomena exhibited by prisms is that of refraction. A prism is a solid piece of glass with flat polished surfaces. So prism is shown, a convex lens, a concave lens, convex lens also called converging lens, concave also called diverging lens, and mirror is shown. So these are basic optical devices: prism, mirrors, lenses. Now what is optical system? An optical system is a collection of mirrors, lenses, prisms or other optical elements that perform a useful function with light. Characteristics of optical system are the location, type and magnification of the image produced, the amount of light that is collected, the accuracy of the image in terms of sharpness, color and distortion, the ability to change the image like a telephoto lens on a camera, the ability to record the image on film or electronically. So these are all, they are characteristics of an optical system. So now let's quickly go through this phenomena of reflection before we start with some numericals. So reflection may image appear in mirrors because of how light is reflected by the mirror. The incident ray follows the light falling onto the mirror. The reflected ray follows the light bouncing off the mirror. So this phenomena of reflection is shown. This is how we see our image in a mirror. A real object is there and its virtual image is here. जितना object mirror के आगे है, in front है, image उतनी ही पीछे है. So it is shown here. The specular reflection, in specular reflection, each incident ray bounces off in a single direction. A surface that is not shiny creates diffuse reflection. So when the surface is very smooth, polished, the reflection is specular reflection. But when the surface is not shiny, that is the surface is rough, then the reflection is diffuse reflection. So in diffuse reflection, a single ray of light scatters into many directions. So this is shown, ये specular reflection है, one incident and one reflected ray. But in diffuse reflection, for one incident, there can be many reflected rays. Here the surface is polished, smooth, here the surface will be rough. So this is the difference between specular reflection and diffuse reflection. So next, laws of reflection. So this picture show the phenomena, this diagram show the phenomena of reflection. The incident ray strike the mirror, the reflected ray bounces off, the angle of incidence equal to the angle of reflection. So this is first law of reflection, angle of incidence is equal to angle of reflection. So it is shown here, mirror, incident ray, refracted ray. This is normal, normal means perpendicular to the plane, angle of incidence and angle of reflection. So next is law, second law of reflection. A light ray is incident on a plane mirror with a 30-degree angle of incidence. So question is there, sketch the incident and reflected ray and determine the angle of reflection. So what is given to us, that the angle of incidence is 30 degree. So find the angle of reflection and also sketch the ray diagram. So this is ray diagram, incident ray, normal, reflected ray, and from laws of reflection we know that angle I is equal to angle R. So naturally the reflected angle will be same as incident. So I is equal to R, both are 30 degree. Next question is, a dentist uses a mirror to look at the back of a second molar, A. Next she wishes to look at the back of a lateral incisor, B. So which is 90 degree away. So both are 90 degree away. By what angle should she rotate her mirror? So by what angle should she rotate her mirror? So options are A 90 degree, B 45 degree and C 180 degree. So a fact we know about this reflection is that when the mirror is rotated by an angle theta, the reflected ray is rotated by twice of theta. So that means if you have to rotate the image by 90 degree, the mirror will be rotated by half of this, that is 45 degree. So the answer will be 45 degree. So by what angle should she rotate her mirror? The answer or the solution is 45 degree. So now specular versus diffuse reflection. So this image, this depicts, it shows specular reflection. So for one incident ray, only one reflected ray is there, and angle of incidence is equal to angle of reflection. Surface is smooth, polished. The surface is flat at distance scales near or above the wavelength of light. It looks shiny like a mirror. While in diffuse reflection, just see here, the surface is rough, it is not smooth, it is not polished. So in this case, angle I will not be equal to angle R. So this is diffuse reflection. The surface is rough. Almost all surfaces reflect in this way. So this was diffuse reflection. Another question, two plane mirrors form a right angle. How many images of a ball can you see in the mirror? So two plane mirrors, they are placed at right angle to each other. A ball is here, observer is here. You have to find how many images of the ball the observer can see. Options are A is 1, B is 2, C is 3 and D is 4. So the answer is 3. There are three images possible. So next, let's quickly go through refraction. What is refraction? And then we will solve few problems on refraction. So light rays may bend as they cross a boundary from one material to another, like from air to water. So when light goes from one transparent medium to second, that is example from air to water, it will change its path. So ray will bend. This phenomena is called refraction. This bending of light rays is known as refraction. So this is shown here. A straw is placed in a glass of water. The refracted image of the straw, it appears raised. So this is because of refraction. The light rays from the straw are refracted or bent when they cross from water back into air before reaching your eyes. When a ray of light crosses from one material to another, the amount it bends depends on the difference in index of refraction between the two materials. So the amount by which the ray is bent, जितने उसको bend हो जाती है, वो किस पे depend करता है? Refractive index पे. Depends upon the index of refraction of the two mediums or two materials. So just see here, two examples are shown here. One is refraction from air into diamond. Second is refraction from air into water. So the refractive index of air is 1, but that of diamond is 2.42 and that of water is 1.33. So in first case, refraction from air into diamond, just see the angle of refraction is 28 degree, whereas in the second case the angle of refraction is only 13 degree. So this angle of refraction or the amount of refraction or the amount the rays bend, they depend upon the refractive index of the medium. So refraction is the bending of light as it passes from one medium to another. From examples shown here, from air to water, this is angle in air and this is angle in water. We say this is angle of incidence and this is angle of refraction. Note the angle of incidence theta A in air and the angle of refraction theta W in water are each measured with the normal. So these angles, they are measured with respect to the normal. The incident ray and refracted ray lie in the same plane and are reversible. They are interchangeable. If this is incident, this will be refracted. If this is incident, this will be refracted ray. So incident and refracted rays, they are reversible. So here air, glass and water. So the compound medium is shown here. So light first enters from air to glass and then from glass to air. So this is refraction from air into glass, and this shows refraction from glass into air. So this is normal, angle of incidence, angle of refraction. So the angle of refraction of first case will be angle of incidence of second case. Both these angle will be same. So the angle of emergence, you can say this will be same as angle of incidence, because finally the light is again coming in air. From air it is going back into air. So these two angles, angle of incidence and angle of emergence, will be same. Now next, calculate the angle of refraction. So we will solve few problems on this topic of refraction. A ray of light traveling through air is incident on a smooth surface of water at an angle of 30 degree to the normal. So angle of incidence is 30 degree, light is air, ray is entering from air to water. So calculate the angle of refraction for ray as it enters the water. So what we have to find is, we have to find the angle of refraction. So we are asked to find the angle of refraction. What we are given? We are given angle of incidence, that is 30 degree according to Snell's law. So Snell's law, this gives us refractive index in first medium, or you can say incident, into sin theta 1 theta incident जिसमें medium air, in this case it is air. So this is nr sin theta r. So ni is air, its refractive index is 1. nr, the second medium, is water, its refractive index is 1.33. Applying Snell's law to find theta r, substituting these values of ni and nr and also theta I. So we get 1 into sin 30 is equal to 1.33 into sin theta r. So sin theta r, this will be equal to sin 30 is 1 by 2, that is 0.5. So 0.5 divided by 1.33. So solving this comes out to be 0.376. So sin theta r is equal to 0.376, and finding the inverse sine function, the value of the angle theta, theta is sine inverse 0.376, this comes out to be 22 degree. So using Snell's law we can solve this problem. The solution comes out to be 22 degree. Now this refraction, the phenomena of refraction, this distorts vision. So what happens, just see, if you dip a pencil in a water, in a glass of water or tumbler of water, so to the observer it appears raised. Similarly, a fish in a pond, it appears raised to the observer. So why this is happening? This is due to refraction, because due to refraction the rays appear to diverge from this point. Actually they are refracted after entering from water to air. When they enter from water to air, the rays are refracted. So it appears to the observer as though they are coming from this point. So the image of the object is seen here. So we say this is the real depth of the object and this is the apparent depth. So real depth is always greater than apparent depth in case of refraction. So the eye, believing that light travels in straight line, sees objects closer to the surface due to refraction. Such distortions are common. So fish, it is really here, actual position of fish is here, but it appears that it is here. Similarly, a fish out of water, the eye sees the object at a distance d when it is not in water, but when it is water, when the fish is in aquarium, the eye sees the image at a distance d dash. This is due to refraction. So diverging rays appear to come from this point. This is a virtual image. So if it is placed outside water, so there is no problem of refraction. So the eye observe the object at its normal distance जहाँ पे वो है. The eye sees the object at a distance d, but when the fish is in aquarium, due to refraction, the rays, they are diverging and the diverging rays appear to come from this point, and this is the virtual image of the fish. So this is apparent depth. So a question is here now, a fish swims below the surface of the water. An observer sees the fish at. So observer is here, a fish is swimming in the water. So an observer sees the fish at, कहाँ देखेगा वो? Option A is a greater depth than it really is, its true depth, or a smaller depth than it really is. So observer को fish कहाँ दिखेगी? इसकी true depth पे, या greater depth पे, या smaller depth पे? So the answer is a smaller depth than it really is. So fish will appear raised to the observer. So this will be the virtual image of the fish. So observer को fish यहाँ पे दिखेगी. Another example question, fish swims directly below the surface of the water. So now the position of the fish is here and observer is here. An observer sees the fish at, now again, a greater depth than it really is, its true depth, or a smaller depth than it really is. So again the answer is a smaller depth than it really is. Now next, what is this index of refraction? We are going to define it. The index of refraction for a material is the ratio of the velocity of light in vacuum to the velocity through the material. So velocity of light in vacuum is 3 into 10 power 8 meter per second, and the second medium which we are talking about. So refractive index of a material is the ratio of velocity of light in vacuum to that of the velocity through the medium about which we are talking. Then index of refraction, this is given as n is c upon v. C is velocity of light in vacuum and v is in the medium. So n is c upon v. C is velocity in vacuum or air and v is in the second medium. So n is given as c upon v, n is index of refraction or refractive index. Examples, for air n is 1, for glass refractive index is 1.5, and for water refractive index is 1.33. So from this expression, if we know refractive index, you can also find the velocity. So instead of writing n is c upon v, we can also write that v is c upon n, and we can find the velocity of light in the medium if we know its refractive index. C is a constant, all of us we know its value. This is 3 into 10 power 8 meter per second. So V medium is the speed of light in a transparent medium, C is the speed of light in vacuum, N is the dimensionless constant, that is refractive index or index of refraction. The value of N is 1 in vacuum. The ability of a material to bend rays is described by the index of refraction. So what do we mean by refractive index? What does it determines? It determines the ability of a medium to bend the rays of light. So her table is given here. Material, say for vacuum this refractive index is 1, for air its value is 1.0001, for water refractive index is 1.33, ice के लिए 1.31, glass 1.5, and for diamond this is 2.42. So refractive index, it describes the ability of a material to bend the rays of light. Now let's solve few examples. Example 1 is light travels from air into glass. Light travels from air into glass, where its velocity reduces to only 2 into 10 raised to the power 8 meter per second. What is the index of refraction for glass? So velocity of light in glass, it is given that 2 into 10 power 8 meter per second, and refractive index of air is also given, this is 1. What we have to find is, we have to find the refractive index for glass. So we know refractive index, and this is given as c upon v. So c velocity we know of light in vacuum is 3 into 10 power 8, glass में given है 2 into 10 power 8 meter per second. Solving this refractive index for glass comes out to be 1.5. So refractive index of glass is 1.5. if the medium were water, अगर यहाँ पे हम water लेते instead of glass it was water, तो this value of refractive index it come out to be 1.33. Then you should show that the velocity in water should be reduced from c to 2.26 into 10 power 8 meter per second. So अगर medium glass है तो refractive index उसका 1.5 आएगा और velocity is given 2 into 10 power 8 meter per second. और अगर एयर की बजाय यहाँ ग्लास की बजाय इफ़ यू टेक वाटर एज द मीडियम, तो वाटर का अगर रिफ्रैक्टिव इंडेक्स 1.33 लेते हो तो वेलोसिटी की वैल्यू विल कम आउट टू बी 2.26 into 10⁸ meter per second. So you can compare this refraction. Here an analogy for refraction is shown. Just see here. Light bends into glass, then returns along original path, much as a rolling axle would when encountering a strip of mud. So just see what is happening. Light air से आई, glass में गई, bend हुआ path, again it comes into air, so it follows the original path. It follows the original path or it returns along the original path. So same thing happens with the rolling axle. It is moving here. It will pass in the sand. When it will pass in the sand, it will change its path. Why it will change its path? Because velocity in sand is less than velocity on pavement. So that's why it bends just like the rays bend here. But when it again enters the pavement, it will follow the original path. In the same way, the ray of lights, they will follow the original path. The velocity of light in air is same, 3 into 10 power 8 here, 3 into 10 power 8 here. So the path is also same. Now this Snell's law of refraction, we will see it's different, we can represent this Snell's law in different ways. So just see, Snell's law is the relationship between the angles of incident and refraction and the index of refraction of both material. So this is a relation between angles and refractive index. So angles and refractive index of the two mediums, we say this is Snell's law. So Ni sin theta I is Nr sin theta r. I stand for incident and R stand for refraction. So this is one form of Snell's law, but it can be written in other forms also. Now we will discuss all those forms one by one. So this N1 is refractive index of incident medium. This is angle of incidence theta 1. This is refractive index of second medium, refractive material, and this is the angle of refraction. So this is first form of Snell's law. This is angle of incidence, refraction. So N1 sin theta 1 is N2 sin theta 2. The ratio of the sine of the angle of incidence theta 1 to the sine of angle of refraction theta 2 is equal to the ratio of incident velocity v1 to refracted velocity v2. Now here comes the second form of Snell's law. That means now this ratio of sine of angles, this can also be represented as ratio of velocities. So previous slide में हमने क्या देखा था? This is ratio of refractive index. So sin theta 1 upon sin theta 2, you can write this as N2 upon N1, where N1 and N2 are refractive index. So now this is the second forms of Snell's law. Here this ratio of sine of angle of theta 1 and theta 2 can be represented as ratio of velocities. So velocity in first medium, velocity in second medium. So sin theta 1 on sin theta 2 is equal to V1 upon V2. So this is the second form of Snell's law. This can be written as ratios of velocities. So let's solve a problem based on this formula. A laser beam in a darkened room strikes the surface of water at an angle of 30 degree. So angle of incidence is 30 degree. The velocity in water is 2.26 into 10 power 8 meter per second. What is the angle of refraction? So we have to find the angle of refraction. So given is incident angle. So incident angle, it will come out to be 90 minus 30. So it is given that it strikes the surface of water at an angle of 30 degree. So it is not that given that the angle of incidence is 30 degree. So we have to find the angle of incidence and it will be 90 minus 30. So angle of incidence here is 60 degree. So using Snell's law, second form of Snell's law, that sin theta in air divided by sin theta in water is velocity in air divided by velocity in water. So substituting the values, this refracted angle of refraction, that is sin theta w, this will be velocity in water into sin theta a divided by velocity in air. So substituting the values, this comes out to be 35.3 degree. So the angle of refraction, that is in